All right, so we're working on this problem. It says there are 8 alcohols with this molecular formula. So alcohols, we know, is an OH group, and there are 8 of them, and 5 are shown, and it says there's 3 that are missing. So I want to show you how we might go about finding the answer to this. So I'm going to rotate around and show my paper here real quick. All right. So I like to draw these out by hand rather than doing it on the screen, as you may as well, because it's really way faster, at least for me it is. So here's the idea. You've got these carbons, and they'll be in this carbon chain here, like this, and this is a C5H12O. So that would be 1, 2, 3, 4, 5 carbons. Oops, let's get the focus working correctly here. Okay. I'm having trouble with it still. And that'll be like hydrogens connected to each one. We don't need to draw out all the hydrogens. Maybe I can get the focus. There we go. All right, so that'll be 3 hydrogens connect to that one, 2 hydrogens connect to this one, 2 hydrogens connect to this one, 2 hydrogens connect to that one, 2 hydrogens connected to this one, and then the OH at the end. So you don't need to draw out each one of those bonds, just condense it down to this so we can see pretty quickly how that works. So you can count it all up. That's 1, 2, 3, 4, 5 carbons. 1, 2, or start out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. So that is one isomer of C5H12O, and it is an alcohol because it has the OH group. All right, so they kind of, in this problem, they separated them essentially into 3 different categories. So one of them, the first category was a 5 carbon chain. And what we're saying there is that the parent molecule is a 5 carbon chain. So the idea is that that's 1, 2, 3, 4, 5 in a row, and then an OH off of it. Where there would be a different way to do this if it were a 4 carbon chain. Like this. So it'd be 1, 2, 3, 4. So that would be H3, H2, 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 and then of course you'd still have the alcohol group coming off over here. But that would not be the same molecule, right? So where one of these hydrogens is, actually there's going to be a branched carbon coming off. So instead of 2 hydrogens there, we're going to put just 1 hydrogen and branch a CH3 off of there. So it's bonded to 3 hydrogens and then back to that carbon. And then now we have back the same number of carbons, same number of hydrogens. 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, 1 oxygen. So we're looking at the same molecule there again. And that would be with a parent chain of 1, 2, 3, 4 carbons. And then last, they've separated into a category that has 3 carbons. So it would be carbon, 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 and then that would have 3 hydrogens on it, 2 hydrogens on it, the OH group coming off it, and then this one would have 2 carbons coming off it. So that would be a CH3, CH3. We can count it up, and again, it'll be the same. 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. Oops. Sorry, that was a little bit off the screen. I'll count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, 1, 2, 3, 4, 5 carbons, 1 oxygen. So it's the same molecule, but the parent chain that has the alcohol in it is 1, 2, 3. Okay, so those are 3 categories, but it told us that there were actually 8 alcohols. So that means in these categories there must be other alcohols that we could make. So how does that work? Basically, it's just move where the alcohol is attached. So if we redrew this, we could attach the alcohol before we put the hydrogens in. 1, 2, 3, 4 carbons, 5 carbons. Instead of attaching the alcohol over here, let's attach the alcohol just one in from there, and then fill in the rest of the hydrogens needed. And I'm just filling in to make 4 bonds around each carbon. You could draw out the full Lewis structure, but you'd see it works out essentially the same way. Sorry, I'm scooting over here. The sun's coming in the window, messing up the lighting. Okay, so that's another isomer of this one with a 1, 2, 3, 4, 5 carbon chain. The next one would be where the alcohol moves over one more to the middle carbon. So you'd have 5 carbons in a row. 1, 2, 3, 4, 5. The alcohol is coming off here. And then the carbons on the end get 3 hydrogens because that's what they need to make 4 bonds. The one here gets 2 and 2, and the one in the middle gets just 1 hydrogen. You could count them up: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It still works out the same way. All right, so we're getting closer, right? We found 1, 2, 3, 4, 5 of them, but we need to find 8 total. We can't move it here, and I'll show you why. Because this one, if you put the OH here, that would be just the same as putting it here. Because if you start counting from this end, this would be the first carbon, and that would be the second carbon. And so the OH was attached to the second carbon. If you put it over here, you would just be like counting 1, 2 from this end, essentially just flipping the molecule around. It wouldn't actually be a different molecule. All right, so we go next to this one down here, and we can move the OH over as well. And we'll just literally, instead of putting it on this first carbon, we'll put it on this second carbon. We'll take away that H, we'll put the OH there instead. So we'll make 4 carbons. So here, we'll put the OH, we said we're putting it on the second carbon, so there's the CH3, and there's the OH. So you've got same molecule, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, 1, 2, 3, 4, 5 carbons, and the oxygen as well. And you've moved it over there. Same thing, move it over one more. That's different because now it's attached to the next carbon in the chain, but it's different than being on the first one. It's different than being on this second carbon because this second carbon is on the same carbon as the branch is coming off of. So there's another one, and with this one we actually have one more. We could move it over here to come off of this carbon, and that would be different because if it's on this first carbon in the chain, then that's the one just right next to the branched carbon. If it's here, it's the one next to a single carbon and then next to the branched carbon. So it's a slightly different molecule. So we'll put our 4 carbons in the main chain. We'll branch our 5th carbon off of it down here. and we'll branch the OH off of this other end. You could add it up, it'll still add up to the same number of carbons and hydrogens. So now we've gotten to 1, 2, 3, 4, 5, 6, 7, 8 isomers. So that's it. The task is just to find which ones weren't originally listed there on the screen. So you'll come back over to the screen and you'll compare each of the isomers that we drew here with each of the isomers on the screen. You'll say which one's missing, and that's the ones that you'll draw in down below. Thanks for hanging with me. Happy studying.